Hey everyone, welcome back. Today we're diving deep into how companies are using data to predict when machines will break down.
And they're doing it before it happens.
Exactly. Think about how much money and hassle that could save.
Oh, absolutely. Some companies are seeing a 40% reduction in unplanned downtime.
40%. Wow. So where do we even begin with something like this?
Well, our source today is an article from XLM's Continuous TV Weekly newsletter, published on November 13th, 2024.
Okay.
It's called Industrial DataOps, Part 3 DataOps plus Continuous Predictive Maintenance, cPdM. It's a great place to start.
So this deep dive is all about cPdM.
Yeah, it combines the power of industrial data ops, which is all about handling data, with cPdM, which focuses on using that data to predict equipment failures.
Got it. So it's like a well-oiled machine for collecting and analyzing data to keep those other machines running smoothly.
Exactly. And the first step is gathering the data itself. We put sensors on all kinds of equipment, like vibration sensors to pick up shakes, temperature sensors to monitor heat, and even acoustic sensors that can hear weird sounds.
So we're giving these machines a full checkup.
Yeah, pretty much. We're also pulling in data from those maintenance logs and operational data.
So it's like a medical history, a daily journal, and a fitness tracker, all for each piece of equipment.
That's a great analogy. It gives us a complete picture of what's going on.
So what happens once we have all this data?
Well, we can't just throw it into a magic algorithm and expect prediction.
Right. There's got to be more to it than that.
Absolutely. There's a lot of data preprocessing.
Yeah.
Cleaning, organizing, and preparing the data for analysis. It's like baking a cake. You wouldn't just dump all the ingredients in a bowl without measuring or mixing. Right.
No, definitely not. That would turn out well.
Right. So we need to handle things like missing data points and smooth out outliers.
So you're making sure the data is clean and ready to be used.
Exactly. But then we need to transform this raw data into something that can predict future failures, right?
How do you do that?
That's where feature engineering comes in. We're taking that prepped data and turning it into something the machine learning models can actually understand and use for predictions. Like, say we notice that a particular vibration pattern always appears right before a machine breaks down.
Okay.
We can teach our models to recognize that pattern and flag it as a warning sign.
So it's like those subtle signs that tell you your car needs a tune. A little rattle here, a weird noise there.
Exactly.
You learn to recognize those patterns and address them before they become big problems.
Exactly. And there are other techniques too, like frequency analysis, where we look for repeating patterns in the data.
So it's a bit like listening for that one instrument in an orchestra that's slightly out of tune.
Yeah, that's a great analogy. And sometimes there's just so much data that it can be overwhelming for the models to handle, so we use dimensionality reduction to focus on the most important data points.
Okay, so you've gathered the data, prepped it, and transformed it into something useful.
Right.
This is where the real magic happens, right?
Right.
The part where we actually predict when a machine might fail.
Exactly. We use machine learning models. There are different types, each with its own strengths. Some are great at capturing trends over time, while others are better at categorizing equipment as healthy or needs attention.
So like some models are like detectives looking for patterns over time,
Yeah,
while others are like doctors doing a quick triage.
exactly. And the choice of model depends on the equipment and data. What's fascinating is that these models can learn from historical data to predict future failures with surprising accuracy.
Okay, so now we've got these powerful predictions, but how do we actually get these insights to the people who need them?
Well, that's where things get really interesting. We'll talk about that in the next part of our deep dive. Stay tuned. One of the most exciting things is how we can take complex data insights and make them easy for anyone to understand.
Oh,
Imagine dashboards that light up with clear warnings when a machine's showing signs of trouble.
kind of like a check engine light for your car.
Yeah,
Huh.
but way more sophisticated. These dashboards can be tailored for different people, too. An engineer might want to see detailed sensor readings and trends, while a manager might just need a quick overview of, potential downtime risks.
It's like a customized control panel for each person.
Exactly. And the best part is this approach isn't just theoretical. Companies are using it and getting amazing results.
Really? Tell me about a success story.
Well, there's this manufacturing plant that was having issues with one specific piece of equipment.
Okay.
It kept breaking down unexpectedly, causing huge delays and costing them a fortune.
I bet that was stressful.
Yeah, they were losing thousands of dollars every hour that machine was offline.
Ouch.
So they decided to try out cPdM. They attached vibration sensors to the machine and gathered all sorts of data.
Like historical maintenance records.
Yeah, and operational data, everything they could find.
So they were playing detective?
Uh-huh, pretty much. What they discovered was fascinating. Certain vibration patterns always appeared right before the machine failed. They also realized that the machine was sometimes being pushed too hard.
So they found the warning signs.
Exactly. So they built a predictive model that could forecast when the machine was likely to fail.
Oh, wow.
And they integrated this model into their maintenance system, so technicians would get an alert when the machine was approaching a critical threshold.
So the machine could basically say, hey, I need a checkup soon.
Haha, yeah. And because they could anticipate these failures, they started scheduling maintenance during planned downtimes.
So no more scrambling to fix things at the last minute.
Exactly. They saw a huge decrease in unplanned downtime and saved a ton of money on maintenance.
So they improved their operations and their bottom line.
That's right. It's a win-win. And we're seeing similar success stories across all sorts of industries.
It's incredible. It makes me wonder, if we can predict when machines are going to fail, what else can we predict?
Now, that's a fascinating question, and one we'll delve into in the final part of our deep dive.
You know, it's pretty amazing that we can use data to predict something as complex as a machine failure.
It really is.
What else could we predict if we had the right data?
There are so many possibilities. Think about healthcare. Imagine using data from wearable sensors and medical records.
Okay.
Maybe even genetic information to predict someone's risk of developing certain diseases.
So instead of just reacting to health problems, we could prevent them.
Exactly. It'd be like a personalized early warning system for your health.
Wow. That's incredible. What else?
Well, we could predict traffic patterns in cities, optimize traffic flow, and reduce congestion.
Okay, yeah.
Or we could use data to forecast energy consumption in buildings, making them more efficient.
So we could create smarter systems.
Yeah, systems that adapt to changing conditions in real time. And we're already seeing this happening.
Oh, really?
Cities are using data to manage traffic lights better, and companies are using data to optimize energy usage.
It's exciting to think about all the ways we can use data to improve things. But even with the best data and algorithms, it all comes down to people, right?
Oh, absolutely. The human element is crucial. We need people to interpret the data, make decisions, and take action.
So clear communication is important.
Definitely. We need to explain complex insights in a way that everyone understands, from engineers to executives.
So it's not just about data scientists. It's about everyone understanding and using data.
That's a great point. And it's not just one-way communication either. We need feedback loops so people can share their observations and help us make the models better.
So it's a collaboration between humans and machines.
Exactly. And that's what's so exciting. We're just scratching the surface of what's possible.
It seems like we're on the verge of a data-driven revolution.
I think so too. It's an exciting time.
Well, that's the end of our deep dives into industrial DataOps and continuous predictive maintenance.
It's been great sharing these insights.
We've explored how data is transforming industries and talked about the potential to impact other areas of our lives.
Hopefully you've learned something new about the power of data.
The future is data-driven, and we all have a role to play. So stay curious and keep learning. Thanks for joining us on The Deep Dive.